Welcome to Dimensional Analysis, the nuts and bolts of creating ratios between units. In this video, we will define what dimensional analysis is. We'll figure out what a conversion factor is. We'll learn the rule for selecting a conversion factor. And finally, we're going to learn 4 steps for solving problems involving dimensional analysis. So, let's get started. What is dimensional analysis? Well, dimensional analysis is also known as the factor label method, and it's a system or a method used to convert data from one type of a unit to another type of a unit. In dimensional analysis, the focus is always on the units, and to some degree, we've actually all had experience with this. For example, when you convert inches into feet, you're using dimensional analysis. Or when you're switching from minutes into hours, you're also using dimensional analysis. Both of these are instances when you're using dimensional analysis. Now, whether or not you go through the rigors of the mathematical mechanics, this is what's being used to make both of the conversions you see here on the screen. So with dimensional analysis, we're going to be focusing on the units, converting information from one type of a unit to another type of a unit, and basically the numbers are just coming along for the ride. Now, before we launch into our discussion in dimensional analysis, let's take a moment to review some fundamentals of algebra that are going to be really important to us. Now, with dimensional analysis, you have to be able to manipulate fractions, so we'll start with that. So let's take a look at an equation like this. So here we have 2/3 times 1/2. Now you might remember that when working with fractions, one of the things you do to make it easier to solve is to simplify that equation by crossing out any information that gets replicated in both the numerator and the denominator. So you're looking for numbers that are going to appear both in the top of a fraction as well as in the bottom. And in this example, we have just a situation. The number 2 appears in the numerator in the first term, that is, it appears on the top of the first term, and it also appears in the denominator or the bottom of the second term. And when you have something like this occurs, what are you going to do? Well, you get to cross out these repeating terms. That's what they're called, repeating terms. So we've basically simplified our math at this point, and then if we do the calculation, we're going to see that this ends up being 1/3. So the reason why this works is because when you do the math in fractions, you're multiplying what's on the top, and then you're multiplying everything on the bottom, and then you're dividing the top by the bottom, so that if before you do all of that, you can eliminate anything before you start multiplying tops and multiplying bottoms. If you can eliminate those repeating terms, go ahead and do it now, because ultimately they're just going to get divided out. And doing it this way just makes it simpler and keeps you from having to do extra steps. So there's our answer, 1/3. Let's take a look at another example. So in this example, we will have 2/3 times 3. Well, you might remember that whole numbers such as R3 can be written like this. We can put it over 1 and turn it into a fraction. Now the reason for that is because any number divided by 1 is that number. So we're not changing anything about the equation, but we are making it easier to visualize where the numbers fall relative to what's in the numerator and what's in the denominator. So when we're expected to perform a function that involves a fraction and a whole number, you can simply convert that whole number into a fraction by putting it over 1. Now we can do one of two things. We can either go ahead and do the math, which means we multiply everything on top and then multiply everything on the bottom and then finally divide the top by the bottom and get our answer, or we can see if there's anything that can cross out and make this equation easier to solve. So we ask ourselves, is there a value that appears in both the numerator and the denominator? And the answer is yeah. That 3 appears in both places. So we know from the previous example that we're going to be able to cross out that 3. It's a repeating term. And now when we multiply top and then multiply bottom, we'll end up with 2 over 1, which can be further reduced to just simply 2, because 2 over 1 is 2. Now in algebra, you also have the experience of working problems like this. where you had both letters and numbers in your problem. And you were taught to treat these letter variables just as you would treat any sort of a number. So in this equation, we can see that we have y's in both the numerator and the denominator, which means that you can cancel both of those because those are repeating terms, right? And now we can just simply do the math, which means we are going to write this as 2/5. Now, when we're working with dimensional analysis, the focus is always going to be on the units, not so much on the numbers, but on the units. And the equations that we set up will require us to be able to manipulate information, not just numbers, but information in the forms of units, just as we would manipulate numbers or variables such as y. And that's why knowing these rules are going to be really helpful to us as we move forward. So let's look at an example. Here we're given a problem that reads, moving at 50 miles per hour, how far are you going to go in 2 hours? Well, this is simple enough for most of us that we can answer this without the aid of paper, pencil, and a calculator. If you're going 50 miles an hour, the first hour you go 50 miles, and the second hour you go another 50 miles for a total of 100 miles, right? But how do we get there? What are the math rules that get us this answer? How is it that we're getting a distance from a given amount of time? Let's answer that by looking at our rate of speed. 50 miles per hour can be written as a fraction. And this fraction is a ratio that tells us that for every 1 hour, a distance of 50 miles is traveled. This rate of speed is establishing a relationship between two different types of units, the mile, which is a measure of distance, and the hour, which is a measure for time. And with this ratio, we can answer the question, how far is being traveled, given that we're traveling for a particular amount of time, in this case 2 hours. Let's set up an equation that shows us how we get this answer. So we're going to take what we're given, which is 2 hours, and we're going to put it over 1 to make it a fraction. Now we do that because the next number that we're going to plug in to our equation is a fraction, and by placing our whole number in fraction form, it makes it a little easier for us to track what's in the numerator and what's in the denominator. And next we're going to multiply this by our fraction, which is our rate of speed, 50 miles over 1 hour. This is the first step in solving our problem. Now we need to ask ourselves, is there anything that we can cross out? Specifically, is there any sort of a unit that we can cross out? Are there any values that appear in the numerator and the denominator? And the answer is yes. The units of hour or hours appears in both places. So we know that we can cross these two out. And with this, we've simplified our equation. Nothing else is going to cancel out, so let's do the math. And we're going to multiply what we have on top, which is 2 times 50 miles. We're going to put that in the numerator, and then we're going to multiply what's in the denominator, which is 1 times 1, put that in the denominator, and we have 100 miles over 1, and if we divide the top by the bottom, that will simplify into 100 miles. Our answer is in miles, which is the unit that measures how far. And we've answered the question that was posed to us, and we have done this through the magic of dimensional analysis. In the last example, we were able to use 50 miles per hour to get the answer we needed. That important bit of information was included in our problem. But what happens when you're not given that information? When the answer doesn't supply you with the relationship between the two different units? Well, we have to come up with one ourselves. We have to create a conversion factor. So then, what is a conversion factor? Well, it's a number that expresses a ratio between one type of a unit and another type of a unit. Or perhaps more simply, it's a number that relates two different types of units. 40 miles per hour is a conversion factor. It demonstrates a relationship between distance and time. More specifically, it demonstrates a relationship between the units of miles and the units of hours. Now there are other examples of this, such as 12 inches to a foot. Inches and feet are clearly different units, but we know there's a relationship between the two, and that is that 12 inches is equivalent to 1 foot. If you measure it out, you're covering the same distance, whether you're reporting it as 1 foot or 12 inches. Or you could say 60 minutes is an hour. It's equal to an hour. Again, minutes and hours are different units, but we know a relationship exists between these two units, and that 60 minutes is the same amount of time as 1 hour. So let's look at this example here. We're being asked to figure out how many feet there are in 48 inches. So let's look at just the units. Now we're given a value in inches right there, 48 inches, and we want to convert it into feet. Well, the math here is pretty simple, but the mechanics of how we get that answer are what I want to focus on. So we're given inches and we want the answer in feet. So we need to create a conversion factor with information that demonstrates a relationship between these two units. And that relationship between feet and inches is this: 12 inches equals 1 foot. We saw in the first example involving 50 miles per hour that we need our conversion factor to be a fraction. So let's do some math magic to make that happen. Let's divide both sides of what we see here by 1 foot. So we're going to divide 12 inches by 1 foot, and then we're going to divide 1 foot by 1 foot. Now on the right side of this equal signs, 1 foot over 1 foot is going to cancel and reduce down to 1. So we can rewrite this as 12 inches over 1 foot equals 1. And is that true? Yeah, it is. But what if instead of dividing by 1 foot, we wanted to divide both sides by 12 inches? Well, let's do that. Let's divide both sides by 12 inches. Well, in this scenario, we have 12 inches over 12 inches on the left side of the equation, and that's going to reduce down to 1, which leaves us with 1 being equal to 1 foot equals 12 inches. And is that true? Yeah, it is. So from our relationship of 12 inches equals 1 foot, we are able to get two fractions that can be used as conversion factors. We could use 12 inches over 1 foot, or we could use 1 foot over 12 inches. Well, if we can have two possible conversion factors, how do we know which one to choose? Well, here's the rule. The rule for selecting a conversion factor is that the units you seek go on top. Let's take another look at our original question. We see that we're given inches, but what we want, the units that we seek, is an answer in feet. So we need to choose the conversion factor with the units of feet in the numerator, and that would be this conversion factor, 1 foot over 12 inches. Let's set up the equation and solve for the answer in feet. So we're going to start with our given, which is 48 inches, and we're going to make it a fraction. We'll put it over 1. And now we need to plug in our conversion factor, which is 1 foot over 12 inches. Now at this point, let's pause and see if there's anything that we can cancel. Are there any units that are going to cancel here? Well, in the first term, we have 48 inches in the numerator, and in the second term, we have 12 inches in the denominator. So yeah, those units are going to cancel. And anything else? Not as far as units go. There are no other units that are going to cancel. So let's, at this point, do the math. So we're going to multiply the numbers on top. We're going to multiply the numbers on the bottom. So we're going to multiply 48 times 1 foot. That's going to give us 48 feet. And then on the bottom, we're going to multiply 1 times 12, which is going to give us 12. So we have 48 feet over 12. And we're going to divide the top by the bottom. So we're going to divide 48 feet by 12. And our final answer is 4 feet, which is what we expected. So the rule for selecting the correct conversion factor requires that you identify the units that you have as well as the units you seek. And that in creating a conversion factor, you make sure you set up the conversion factor fraction with the units you want on top. Because remember, every relationship will have two possible conversion factors. So here are some other examples. We know, for example, that 60 seconds equals 1 minute. These are equivalent measurements. And from this information, we're going to have two possible conversion factors. We can also demonstrate a relationship between two different systems of measurements, such as the metric system and the English system of measurements. 2.54 centimeters equals 1 inch. And from this relationship, we will also be creating two different conversion factors. You can also convert within a system of measurement, such as converting between grams and milligrams. Both are metric measurements, and it's the prefixes that we're going to be converting between. And here too, you can have two possible conversion factors. So with any of these, you would look at what the problem is asking you, look at the units that you're given, and in what units your answer needs to be given, and this will lay the path for choosing the correct conversion factor. So let's work an example. This problem asks, how many centimeters are there in 48 inches? Well, the first thing we need to do is figure out what units we're given, and then figure out what units we need to change our answer into. So we are given a value of 48 inches, so the units that we're given are inches. And the units we want to convert 48 inches into are the units of centimeters. So that's step number one. Second, we need to determine the relationship between the units we're given and the desired units of our answer. Is there a relationship between inches and centimeters? Why, yes, there is. And that relationship is this. 2.54 centimeters equals 1 inch. And from this, we're going to get two different conversion factors. There they are. However, are we going to choose the right one? Well, this brings us to the third step, which is to invoke the rule for selecting a conversion factor, which says that the units you seek go on top. Well, we have inches, but what we seek are centimeters. So what units are going to go on top? The units we seek are centimeters, which means we're going to use the conversion factor on the left, 2.54 centimeters over 1 inch. This puts our centimeters on top. Now let's set up our equation. So we're going to take our given, which is 48 inches, and make it a fraction by putting it over 1. And we're going to multiply this by our conversion factor, which is 2.54 centimeters over 1 inch. Now this brings us to the fourth step in our process. The fourth step in our process is to cross out repeating terms. That is, cross out units that are found both in the numerator and the denominator. We have the units that will cancel out, and these are inches, because we have inches in the numerator in 48 inches, and we have inches in the denominator in our conversion factor. So if we cross those out, then the units that we are left with are the units that we seek, which are centimeters. And now we do the math, which means we're going to multiply the numbers on top and multiply the numbers on the bottom. So if we multiply 48 times 2.54 centimeters and multiply 1 times 1 in the denominator, that's going to give us 121.92 centimeters over 1. At this point, we're going to divide the numerator by the denominator, which is going to be dividing 121.92 centimeters over 1, and our final answer is 121.92 centimeters. Now, I haven't mentioned significant figures because I didn't really want to muddy the waters, so to speak. But if you're in a scenario where you need to be accountable for that, at this point you need to look back to your given value and see how many significant figures are in this value in order to determine how many significant figures your answer should contain. So we need to go back to 48 inches and look at that. 48 inches has two significant figures, so your answer will need to reflect two significant figures as well. So for this problem then, even though we have this lovely number of 121.92 centimeters, it needs to reflect two significant figures. And in order to do that, we're going to change this to 120 centimeters. 120 centimeters has two significant figures. Now, if you don't know about significant figures, or if you're having trouble determining why this is the case, I suggest you go back and you take a peek at my video, Dr. O's 3 easy rules for determining significant figures. It'll make your life a lot simpler. In this example, we are going to convert between grams and milligrams. The question reads, how many grams are there in 1,450 milligrams? Well, we have 1,450 milligrams, and what we want to change that to is grams. So that's the first step in solving these sorts of problems, to figure out what sort of units you're given and what type of units you need to change it into. Now the second thing we need to do is to determine the relationship between the units we're given and the desired units for our answer. So what's the relationship between grams and milligrams? It is that 1 gram equals 1,000 milligrams. And as you know, when you have a relationship like this, you're going to have two conversion factors, and it's our job to pick the correct one. Which brings us to step number 3, which is to use the rule that states the units you seek go on top. And as we seek our answer to be in grams, this will be the conversion factor that we're going to choose. 1 gram over 1,000 milligrams. So let's write our equation starting with our given. We're going to write it as a fraction, which is 1,450 milligrams over 1. And then we're going to multiply it by our conversion factor, which is 1 gram over 1,000 milligrams. Now the fourth step in our process is to cross out repeating terms. That is, to cross out the units that are found both in the numerator and the denominator. If you can do this, you've set your problem up correctly. And in this problem, we have milligrams in the numerator in our first value, and we have milligrams in the denominator in our second value. So we can cross both of these out. And this leaves us with the units that we seek, which are grams, and now we can do the math. We're going to multiply the numbers on top by each other, which is 1,450 times 1. We're going to put that in the numerator. We're going to multiply the numbers on the bottom, which is 1 times 1,000, and put that in the denominator. And you notice there are no units in the denominator. And at this point, we're going to divide the numerator by the denominator, and the value that we get is 1.45 grams. Now we're not quite done. If we look back at our given value, we see that it has 4 significant figures. Because remember, that decimal that we see here in 1,450 means that trailing 0 is important to us. Dr. O's Easy Rules of Significant Figures, rule number 2. So because we have 4 significant figures in our given value, we need for our answer to also have 4 significant figures. So what we need to do is add a 0 to our answer, making it 1.450 grams. And now we're done. So here we've taken 1,450 milligrams and converted it into 1.45 grams. Here we have a problem that is asking how many minutes are there in 1 week. So in this problem, we're given the unit of week, and we're ultimately going to be asked to convert the unit of week into the units of minutes. Now, do we know a relationship between minutes and weeks? Well, we don't have a direct relationship, but there is some things that we do know about minutes and weeks. For example, that there are 7 days in 1 week, and 1 day equals 24 hours, and that 1 hour equals 60 minutes. And we can see that with these 3 pieces of information, there is a way to correlate in an indirect fashion week into minutes. So indirectly, we can demonstrate the relationship, and we're going to use these three relationships to create three conversion factors to do just that. Now, as we know, each one of these relationships will yield two conversion factors, so we will have to choose carefully as we maneuver through this problem. I'm going to solve this problem two ways, and hopefully one of the systems will be easy for you to follow. First, I'm going to solve the problem the way that I have solved all the other previous examples, and then I'll show you the second way so that I can compare it to the one that we've already established. So let's get started. Now, in our problem solving steps, the first thing we need to do is figure out what information we're given, what units we're given, and then figure out to what units we need to change our answer or to give our answer. And we were given the units of week in 1 week, and we're being asked to change 1 week into minutes. So we've accomplished step number 1 by identifying where it is we're starting and where do we need to go as far as our units go. Second, we need to determine the relationship between the units we're given and the desired units of our answer. And we've done that. We're going to have to create three conversion factors to do it, but we've established that there is a way to correlate weeks and days and hours and ultimately minutes. This brings us to the third step, which is to use the rule that states that the units you seek go on top. And in this problem, I'm going to apply this rule as we plug in each conversion factor. So let's get started by setting up our equation. Now we're going to take our given, which is 1 week, and we're going to write it as a fraction. Now in the previous examples, these were pretty simple problems where we had one given unit or one unit that was given, and we had to convert it into another unit. So it was pretty simple. We just converted from one unit to another. Well, in this problem, in essence, we're taking our original value and we have to convert it 3 times before we get the units that we seek. So because we're not doing a direct from here to there conversion, we're more or less eliminating the current unit to move the value to the next conversion factor, repeating that process until we do get to the unit that we seek. So, for the first conversion, we need to get rid of the unit week, which means we will be converting our value into days. So we're going to use a conversion factor that is 7 days over 1 week. Not that we're seeking days, but we need to get rid of week, and in order to do that first step, we're ultimately going to be converting week into days. So let's set that up. So we're going to plug it in here, 7 days over 1 week. Now we have week in the numerator and week in the denominator, so we can cross these two units out. And in essence, we have now converted our units from week to days. But we don't want that, so let's select another conversion factor that allows us to get rid of days. And we're going to use 24 hours over 1 day. So let's plug that in. Now, what we've done so far with both of these conversion factors is we put what it is we're seeking to eliminate in the denominator. By placing the units we want to eliminate in the denominator, we're approaching this problem in reverse. That is, we're not necessarily putting the units we seek on top because we're not seeking days, we're not seeking hours. At least we're not putting the units that we seek on top yet. But by placing the units that we need to get rid of on the bottom, we are moving ourselves further along the process until we do get to the conversion factor that will allow us to put the units that we seek on top. All right, so with 24 hours over 1 day, we now have the ability to eliminate days. And in essence, we've now converted our original value of weeks into hours. Again, we don't want to stop here. We need to do this last conversion into minutes. So we're going to plug in 60 minutes over 1 hour, which allows us to eliminate the units of hours. And at last, we're at the point where we have the units that we seek, which are minutes. And at this point, we have done step number 4, which is to cross out those repeating units, and we can do the math, and by a little magic here we can do the calculation, and our value is 10,080 minutes, and we have solved our problem using 3 conversion factors. Now there's another way to organize this equation so that it's a little easier for some people to visualize, and it's called the picket fence method. And it's the same math, the same approach to conversion factors, it's just set up a little differently. So you're going to start by drawing lines for rows and columns. And then you're going to take your given value and you're going to plug it in the top leftmost corner. Next, you're going to fill in your first conversion factor, which is 7 days over 1 week. You're going to put that in the second column. The numerator is going to go on top, the denominator goes below, and now we can cross out repeating units. Then you're going to add another column, and you're going to fill this in with the second conversion factor, and we can eliminate repeating terms here, which would be days. And then we're going to add another column, and we're going to fill it in with our last conversion factor. And we can cross out repeating units here as well, which will be hours. And we're left with the units of minutes, which is what we want. And now we do the math, and we can see that the answer is going to be 10,080 minutes. Now we've taken the same information, we just set it up a little differently. And I've had students in the past tell me that this second way, using the picket fence method, is actually a little bit easier for them to visualize. You can see comparatively the information is just the same. It's just, you know, how you draw it. So either one of these methods is fine. I'll accept them both on any work that you turn in or the exams. I just demonstrate both of them because sometimes people find one simpler than the other. Oh, and yes, of course, we have to deal with significant figures. So how many significant figures do we have in our given value? Well, our given value was 1 week, which means that we have only one significant figure in 1 week, right? So, well, our final answer actually has 1, 2, 3, 4, 5 digits, 4 of which have any real meaning to us because there's no decimal, but we want our final answer to have the same number of significant digits that our given value has, which means that we're going to have to do some fancy magic here. And the easiest way to express this answer would be to put it in scientific notation. So our final answer would basically be 10 to the 4th minutes, which actually has one significant figure. To recap what we've done in this video, we first off defined dimensional analysis as a system of converting from one type of a unit to another type of a unit. This involved using a conversion factor. And we answered the question of what is a conversion factor. And we said that it's a number that relates two different types of units. And we looked at some examples. And we learned that we're going to have to choose between two conversion factors when there is a relationship between units. And finally, we came up with a way to determine which conversion factor to use. And we said that the units that you seek go on top, which means that the units you seek go in the numerator, and it also means that the units you seek to eliminate go in the denominator. We also used 4 steps in our problem solving. Step number 1 is to figure out what units were given and figure out to what units we need to change it. Step number 2 is to determine the relationship between the units we're given and the desired units of our answer. Step number 3 is to use the rule that states the units you seek go on top. This is how you go about selecting the correct conversion factor. And step number 4 is to cross out those repeating terms. If your repeating terms are the units you wish to eliminate, you should be left with the units you seek. This is your double check to ensure that you've set the equation up properly. And at this point, you just do the math. This concludes our exciting venture into dimensional analysis, the nuts and bolts of creating ratios between units. Thanks for watching.